Today we're going to be confirming roots for polynomials. And one way that we've found roots with polynomials is by factoring. So we are going to begin with practicing a factoring problem. And so we're going to start on the easy end with the 2x because it only factors one way. And we need two factors of 6 that we can put in for the last positions. And 2 and 3, now you would never put a 2 and a 2 together because that creates a common factor, and this polynomial didn't have a common factor. So we're going to put the 3 here and the 2 here, and let's see if that works. That's 4 minus 3, that's 1, but we need a negative 1, so that helps us figure out where to put our negative. And we're going to put the negative here and the positive here. And you set each factor equal to 0 and subtract the 3 and divide the 2. And here, factor equal to 0, add the 2. Alright, now the solution of this polynomial is also called roots. So these are the roots for the polynomial. Okay, we're going to solve again, but we're going to be looking at it as a division problem this time. And the way that we have learned that's the easiest is synthetic division. And you're going to notice that this is the same polynomial, and that is quite on purpose, because I want to show you something. Let's look at this. X minus 2, the root is the positive 2, okay? If you look up here, root is the positive 2. Now, let's divide this synthetically. And we get a remainder of 0. So that means 2 is the root. And we're going to find the other root by writing our depressed polynomial and setting it equal to 0. Now, at this point, what I would like you to notice, 2x plus 3. 2x plus 3. So we subtract our 3, divide by 2, and what do you know? We got the same answer that we got before. So the remainder here is 0. And what we've learned before is that 2 is a root. But guess what? Negative 3 halves is also a root. So what do the factors tell us about the solutions to the equation? The factors contain the roots. You're going to take your factors of x minus x plus, set it equal to 0, and then solve for your variable, whatever that variable is. Negative 1. There's our remainder. Our remainder is 0, so that means yes. This is a yes or no answer, but support your work. Okay, let's try again. Is x minus 4 a factor? So we're going to put the potential root here. Write down your coefficients. And we're going to divide. 4, negative 1, multiply, add, multiply. Well, that is not going to give me a remainder, a 0, so this is not a factor. So to find all the solutions, we're going to use this to help us find all the solutions. The first thing we're going to do is divide, and synthetic division is perfect. So when you divide and you know you have a root, you are going to get a remainder that is 0, and if you don't, you need to go back and check your work. So you're going to divide. If needed, divide again. by another root. This isn't big if, okay? Divide again into the depressed polynomial. Don't go back to the very beginning. In this situation, it is not a good place to start. Okay, you're going to write your depressed polynomial if your exponent is 2. Why that? Because that is quadratic and we can factor it. Okay, then you're going to solve using factoring or the quadratic formula. And step 5, I didn't leave space for it, is write your solution like this, including your original given one, because that number, whatever that number is, that needs to go here also because it is one of the solutions. Alright, let's practice a couple. We're going to start with a root of -1. And we're going to solve the equation. So my first step says we're going to put the root in the corner. 1, -2, -1, 2. And when you're writing your solution, go ahead and start your solution set. Go ahead and write the given one in because that is so easy to forget. So go ahead and take care of that. So let's divide. And then we're going to multiply. And then we're going to add. And then we're going to multiply again. Now, what did I tell you earlier about a given root? If it says that it is a root, your remainder should be 0. If it is not 0, go back and check your synthetic division. Alright, so I've got 3 terms. We've depressed this from a cube down to a square, so we're going to write the polynomial. And this one is factorable, so let's factor it. X into x, and 2 and 1, minus and minus. Set each factor equal to 0 and solve. One, 2. There we go. Solved. Now how do you check? You can plug these numbers in individually back into your equation, and if they make a 0, then you have solved this correctly. So this is definitely a checkable problem. Okay, let's try another one. So we are given that x equals 3 is a root. So I'm going to put my root in the corner, and I'm going to go ahead and start my solution set. Write down my coefficients, like so. And let's divide. Multiply, add, multiply, add. Okay. Good. I did that one right. Now, write down the depressed polynomial. And I think this is also factorable, so let's try it out. This is an easy one to factor. So plus 1 minus, let me see, 2 minus 1 is 1. Okay. Set each factor equal to 0. Going to add 1 and divide by 2. Does factor equal to 0? Whoops. -1. Okay, got my 3 solutions. All done. Now this next problem is something that we have done before. So what we've been looking at is if all roots are known, we've been finding roots, but we want to go backwards. We want to take our roots and we want to find the original equation. So we're going to do this process backwards. The last thing that we did was set factors equal to 0 and solve. We would have our factors subtracted from x. So you have x minus root on and on and on equals 0. That's what you're going to do. If you have fractions, you're going to multiply by the least common denominator. Okay, so let's try this example. Now, let's talk words first. Integral coefficient means no fractions. That's where the multiply by the LCD comes in. Alright, so what we're going to do is we're going to take each root and subtract it from x, or whatever variable you want to use. So x minus -2, that's a plus 2. Then we have x minus 2, and then x minus -3, which is a plus 3, set it equal to 0. And then we're going to begin a process of foiling. Now there's an easy way to do this and there's a hard way to do this. This one, these are difference of squares. That's the easiest thing to FOIL, so let's do that. So x squared minus 4 and x plus 3 equals 0. And then we'll FOIL again. X cubed plus 3x squared minus 4x minus 12 equals 0. And we're done. That was easy. Now I want to give you one more example so you can practice the fractions. And I'm going to give you the roots of 1/2, I know, and 1 and -2. We're also not going to get to do difference of squares factoring this time. So let's try this one out. We're going to subtract each root. And subtracting a negative gives me an addition. Set it equal to 0. Don't skip that step because we're looking for an equation. Now, I really don't want to FOIL 1/2 with any of this stuff yet, so let's do this. Let's do that. Let's save the fraction for later. X minus 1/2, we're going to FOIL x minus 1, x plus 2, so we've got x squared. And if you can do part of this mentally, more power to you. And I am going to do it mentally. You write it out if you need to. Okay, so multiplying this out, you can't FOIL because this has 3 terms. We're going to take x and multiply it by each one of these. And then I'm going to show you kind of a trick to get everything lined up correctly. So I have x times x squared, and then x times x, and then x times -2. Now, when I multiply this other part right here, this is an x squared term, so I'm going to stack it underneath right here. So -1/2 is -1/2 times x squared, and then minus 1/2 x, and then plus 1 equals 0. And I'm going to add them up. So I've got x cubed plus 1/2 x squared. I think that's a 5/2 x, and then plus 1 equals 0. Now, I have a denominator of 2, so that is my only denominator, but I want to get rid of that. So I'm going to multiply everything through by 2, and I can do that because I'm equal to 0. If I wasn't equal to 0, I couldn't do that. So I'm going to have 2x cubed plus x squared minus 5x plus 2 equals 0. Okay, I've multiplied everything out. I have gotten rid of my denominator, so I have integral coefficients. And this is the polynomial I get that gives me these roots.